objective for this lesson is to determine the products of combustion reactions. So let's jump right into it. A combustion reaction are those in which substance reacts with oxygen and heat is released.
Fire.
Hey, you want to see something really cool?
So quite obviously we're talking about fire here. When we're talking about fire in chemistry, we often talk about hydrocarbons, which are a really common combustible molecule. So hydrocarbons are purely just compounds containing only carbon and hydrogen in different varying amounts, and that gives us a different type of hydrocarbon. So when we have oxygen in abundance, we get what's called complete combustion. Complete combustion has the general formula of hydrocarbon plus oxygen gives us carbon dioxide and water. So an example of this would be methane, which has the formula CH4. So we're going to plus O2 and it's going to give us carbon dioxide and H2O. Obviously this does need to be balanced, so we're going to whack a couple of 2's in here, nice and balanced. Now in the event that the oxygen was limited, we get what is called incomplete combustion. Now when we have incomplete combustion, we have two reactions going on. So we have the hydrocarbon plus oxygen gives us carbon monoxide and water. Now obviously we don't like carbon monoxide, this is a toxic gas. We can also, so the other reaction we'll get is hydrocarbon plus oxygen to give us carbon and water. That carbon component is what we call soot. So together with the soot and that toxic gas, we get what we call, and very commonly aware of, smoke. So let's have a look at an example where we have ethane, which is C2H6. So with oxygen, it'll give us carbon monoxide and H2O, and we have to balance that one up. And then we have ethane plus O2 gives us carbon and H2O, and that one also needs to be balanced up. What we're going to do now is a little demonstration to compare what it actually looks like when we see incomplete and complete combustion. So for most combustion reactions, the oxygen reactant comes from the air. So it's not supplied, it just comes straight from the air. Unfortunately, air is only made up of 20% oxygen. So that complete or incomplete combustion will occur depending on how much oxygen is required for the reaction. Let's take a look. Okay, so I've got two little spirit burners. I've got one filled with ethanol and one with kerosene. They're both very flammable liquids, which should give us a nice flame. All right. Can you see any smoke, Alice? Where? Where's the smoke? Around it? Where? Okay, let's compare it. Let's compare it now to the kerosene. Yeah, well, which one's the smoky one? The blue one? Yeah, definitely much smokier. This one I can barely see any smoke at all, if any at all. Very, very clean. This one, very dirty and smoky. Agreed? Agreed. So quite clearly from those results we could see that the ethanol burnt with a clean flame, which we call complete combustion, and kerosene burnt with a dark smoke, indicating that it was incomplete combustion. What I want you to do now is have an attempt at writing equations for the complete combustion of ethanol, formula is given to you, and the complete combustion of kerosene, where the formula is given to you, and make sure that you balance that as well, because it's very important. Just pause it now and take a moment to do that. Okay, what you should have got is ethanol plus 3 oxygens gives 2 carbon dioxides and 3 waters. When we do the complete combustion of kerosene, we're going to get 2 kerosenes plus 37 oxygens gives us 24 carbon dioxides and 26 waters. So the question I want to ask you, and I want you to ask yourself, is explain why you think the kerosene undergoes incomplete combustion. And I guess you need to be looking at that balanced equation and ask yourself what those numbers in the balanced equation tell you. So I'd like to think that you would realize that for the reaction to occur where we only used 2 kerosene molecules, we've actually needed 37 oxygen molecules, which is a huge amount. So it's a very oxygen hungry reaction. And in the case where it's using oxygen purely from the air, there's clearly not enough of it, and therefore it undergoes incomplete combustion, which we evidently saw. In summary, combustion reactions, we have 2 types. Both are pretty straightforward. One is incomplete combustion, where there is not enough oxygen, and the other is complete combustion. Both have simple equations that you should remember and be able to apply to many different situations with many different hydrocarbons.
Cool. Fire, 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 fire.